Hello, how are you doing today? My name is Chris Ayers, and for spring cleaning, we're going to talk about the well-architected architect. Now, a little bit about myself. I'm a senior site reliability engineer inside Azure CXP. So we're part of Azure Engineering, and CXP is the Customer Experience Program, and I'm in Azure. So my job is to help improve the reliability and security of the Azure platform itself. Um, you can look at and reach out to me at a number of different places and socials. I'm on Blue Sky and LinkedIn. I blog, not as much as I should, but you can find all of my talks, all of my samples, all of my demos out on GitHub. And, there's other socials that I visit from time to time. So feel free to reach out, connect, and follow up if you have questions. So as we talk about architecture and being a well-architected architect, I want to talk a little bit at the beginning around solution architecture fundamentals, some things to keep in mind as we go into some of the tools available to you through the Microsoft Well-Architected Framework. We're going to look at some of the pillars, the trade-offs, talk about all of the features that the Well-Architected Framework brings around workloads and service guides, as well as some assessments and other tools that you can leverage to help make your workloads better. So first, when I talk about just solution architecture, there's some fundamentals I think that are great building blocks to use and leverage in your own process. Having a decision-making framework, knowing patterns, and thinking things for future growth. So there's a lot of different frameworks out there for architecture. The Microsoft Azure Well-Architected Framework is one of them. But you need to understand a lot of the requirements that are coming in so that you can make informed decisions. You want to be able to record those. I'm a big fan of what's called an ADR, an architectural decision record. This is a place where when you make decisions, you can actually document that there are 3 or 4 choices. We're looking at these 3. This one makes sense because of this reason. This one makes sense because of that reason. But because of our business requirements, we're going to go with the third option because of the various trade-offs. So like being able to document and communicate your decision process is very helpful as you integrate and interact with other teams and with stakeholders, because as an architect, you're not working alone. You're working with a lot of other teams and stakeholders. So it's important to be able to communicate that and lean on those SMEs, lean on those subject matter experts and those people that have deep knowledge of the business problem in the business space. Understanding cloud patterns. So cloud design patterns are a little different, or can be different, than the traditional patterns you see in an on-premise application, or even in just traditional software design. So understanding that there are some additional pieces of functionality or considerations you have to take around, like latency or retry or cost or scalability. Those really help you plan long term and start understanding those challenges and trade-offs that you're going to have to deal with. Now they constantly evolve. As we learn more information, we build new patterns, we have new capabilities. So part of that is staying on top of things. Just like every plan doesn't survive contact with the enemy, always plan for change. As soon as you build something and release it, or design something and release it, the requirements start coming in to continue to change it or modify it, or it really finds a target in the market or a niche and you need to pivot or adjust. Maybe your budget changes over time. Maybe you have more traffic in one region than another. Maybe there's new regulatory and compliance rules that you need to follow. So if you really lock yourself into one path, you need to understand that earlier, and you need to have considerations for flexibility so that you can adjust things over time. Another one is, how do you run the solution? So can you support it? Like, is this going to be a high maintenance problematic solution if there's some changes or if there's a spike in traffic or growth. So you need to keep in mind the how you observe it, how you monitor it, how you deal with issues that pop up through customers or through the internal teams. Like, there needs to be considerations for all of the exceptional cases that you might see, or even just the day-to-day operations. It's quite possible to design an amazing solution, but then there's this overhead that isn't always considered. So you need to keep that in mind as you go through some of the design exercises. And as I mentioned, things are constantly evolving. So just like we're talking about these things today, continue up with training, even certifications. There's communities that you can go out and engage with. There's a lot of tech people out on Blue Sky, and you can find great discussions on YouTube and books. There's hackathons and conferences. Maintain your skills, because the skills you have today definitely are going to change in the next 2 to 3 years. The requirements change, the technologies change, so you have to not rest on your laurels. You have to understand that things will evolve and change. And make sure that you realize you're not an island of one, that there are a lot of people out there. There are vendors, Microsoft has experts, global integrators have experts, local communities and companies have experts. There are subject matter experts inside your organization. There are people that have deep knowledge of the infrastructure, the code, or the business requirements. Once something's designed, get feedback and consult and ask questions and get validation, because there's always something that you can improve or change based upon that feedback. Like I said, there are lots of different frameworks. There's lots of different approaches. Use what you need to use. Combine them and take the knowledge and use them to the best effect. A lot of methodologies, including the Well-Architected Framework, provide checklists and assessments, design goals and design guides. So they give you lots of tools to leverage different techniques as you go through the design process. And we're going to touch on many of those in my discussion today. So let's dive a little deeper into the Microsoft Azure Well-Architected Framework. Now, this is a framework that gives you a lot of different tools that you can leverage through discussions around workload design. There's reference architectures. There are a number of pillars that give you design principles with checklists and recommendations and trade-offs. We can talk about the advisor a little bit in the Azure portal and service guides. So there is a ton of amazing bits of information and grains of knowledge that you can use and leverage for whatever your workload is and whatever your design goals are. A lot of the goals of the Well-Architected Framework are to have real-world business impact, real outcomes, better resilience in your solution, better security. Microsoft's been pushing SFI, or Secure Future Initiative, for a while now. A lot of that is also baked into our Well-Architected Framework. Many organizations, one of the first things they talk about when they move to the cloud is cost management. They understanding that. And we're going to dive into that quite a bit. A lot of times they're trying to move faster, and this is where operational excellence and leveraging cloud patterns and DevOps and platform engineering can help you. Not only with your development workflows, but your deployment workflows. And then monitoring and automation. Like, can you effectively know the state of your system, the usage of your system, and all of these things are supported and integrated and have give and takes. So you need to understand multiple pillars. You can't just dive in on one and focus on it. You might not understand some of the trade-offs, and that's where this continuous learning helps. I've helped customers implement the Well-Architected Framework. We've had big discussions with large retailers, with financial firms, and we've seen downtime get reduced implementing some of the techniques and design decisions we're going to talk about. We've seen dramatic cost savings for various customers. We've seen teams be able to deliver more features faster by really diving into operational excellence and agility and leveraging all sorts of ways to build and deploy software quicker and monitor their deployments and applications to be able to react better. So we're going to talk about all of these as we go through these different pillars. And at the end of the day, whether you're working on Azure or whether you're working on any platform, you're going to be able to think about problems in a slightly different way that is going to help drive success, better resilient workloads, better security, and understanding the risks inherent to the design you're putting out there, better cost optimization. And this can apply to a lot of different, like I said, clouds and solutions, because a lot of organizations do multi-cloud solutions. But we're going to dive into a lot of the Azure specific ones. So let's get into it. There are 5 pillars that are the focus areas of the well-architected framework. Reliability, where we care about the resilience of our systems, availability, and recovery. So if something does go down, how quickly can you get it up? Security, like we want to make sure our data is protected, that we understand threats and can respond to them. Security, identity, these live in this pillar. Cost optimization. So it's not just about keeping our costs low. You have to understand maybe your budget, identify waste reduction, set up cost monitoring, know where those dollars are going. We'll definitely talk about this. This is usually a very popular topic that gets lots of questions. Operational excellence. This one's near and dear to my heart. I'm a big DevOps fan, and I'm one of the organizers for DevOps Days Tampa Bay. And I speak around this a lot, and I'm an SRE. So understanding observability. What is the state of your system? Is it up or down? What's your response times? How are you building and deploying solutions? How are you doing rollback? And do you have procedures for incidents? So operational excellence is something that I live every day. And finally, performance efficiency. Every customer has different performance needs. Sometimes they need instant response on some detailed analysis. Other times it's that trade-off with cost. Maybe you're a global retailer and you need to handle Black Friday or some large viral event that happened and you have this massive spike in traffic. So you need to be able to scale. So we'll talk about how you can plan for those type of activities. Let's dive deep into the first pillar. So reliability. The reliability design principles really are around understanding that whatever your goals are for your workload, whatever the business requirements are, it needs to be able to deliver that, whether there's an outage or a malfunction or whatever. Now, I don't know what that functionality is. This is where there's this deep partnership with you in the business. Maybe it's a user experience. I need the page to load within 100 milliseconds. Now that might mean it needs to load within 100 milliseconds, whether there's 2 data centers out, or it needs to load within 100 milliseconds, no matter how much user traffic is hitting it. So you need to start to understand and think about what are the actual requirements that you're measuring against for this reliability. Maybe it's I need to be able to persist this amount of data, or I need to be able to load the web page, add something to my cart, and check out, no matter what's happening. Now, there can be core functionality that you care about. Like I said, I want to see the catalog, I want to add items to a cart, I want to check out. But maybe you have optional requirements that are there when there's not an issue. Maybe that full functionality includes additional marketing components. Maybe it does a recommendation engine. Maybe there is advertisements, or other customers like you have liked this item. But when you're under load, or it's Black Friday, or there's an incident or an outage going on, maybe you reduce some of that load and traffic by not doing the marketing engine or not doing the recommendation engine. But you can still deliver that core bit of requirements that need to survive that outage, being able to see what's available, being able to add it to your cart and check out. So understanding that there are some requirements that are absolutely core to the experience, and some might be optional or eventually consistent, and that factors into the reliability architecture. Recovery. So, understanding things like RPO and RTO, the recovery point objective, recovery time objective. Like, how quickly does the system need to get back up if something does happen? And that varies based on the size of your organization. The requirements that someone like a very, very large global retailer has might be a little different than a small mom and pop. So understanding that range of I need to get it back up as soon as possible, it might be within the week versus, hey, we need to fail over to the secondary system within seconds. That is a dramatic shift in architecture, but understanding those core requirements are important. And, like I said, with operations, it's really important that you understand the system goes down. So that might mean that you have monitoring in place to know that there was an incident or an outage. You might have monitoring in place to understand a malfunction or a bug occurred. And so this touches on operational excellence. A lot of these are interconnected. I will note that last point about simplicity. A lot of times, if you deal with layers of architecture and multiple teams all trying to architect for reliability or performance or cost, what you might see is over-engineering. You might assume that you need that global retailer architecture for every single problem, and you might not. You also might go, hey, I'm going to bump the numbers up on the SKU or the number of instances so that we can handle an outage. And then you pass it up the chain and someone else bumps up the numbers a little bit, trying to add a buffer. And so you can add buffers on buffers on buffers and start getting just large, overcomplicated mess. So usually simplicity with the availability to scale or do additional stamps is the best way to go. So again, this is where we talk a little bit about failure mode analysis. What is the failure mode you're trying to succeed? Are you trying to survive a data center outage? So for smaller or medium-sized businesses, a single data center outage might be painful. But if you want to survive that, maybe you look at something like availability zones, which is something a lot of services offer. Those are available in multiple clouds. And so I can have multiple data centers in a single region. And so if one data center goes down, I can still serve my customers. That might be all you need. If your failure mode is, I just want to survive a data center outage, but I'm fine as long as the region is up. That's perfectly acceptable for a large number of customers. Maybe you have a nationwide solution and a single region going down, which is very rare, but if a region goes down, East US goes down, but you still need to be able to serve customers. Now we got to look at, well, I need a multi-region solution. So my failure mode is I can't survive a regional outage, I need a multi-region. Well, as you start adding regions and you start expanding that window, you run into things like, now I have to do multi-region redundancy. So what's going to be my data store? Am I going to go hot, hot? Am I going to go hot, warm? Am I going to do log shipping? Am I going to do failover? Am I going to change my data store so that it supports multi-region reads and writes? These are considerations. So the complexity usually goes up quite a bit as you start handling more and more failure modes. Another common scenario we see is something went viral, or it's a day where they expect a huge surge in traffic. So reliability in that case might mean having more instances. It might mean adding more regions with load balancing, but you still have that underlying problem of maybe data persistence or routing traffic between various regions and data stores. So that is usually the biggest challenge people have when they're striving for reliability. Now, again, best practices are, if you do this, leverage automatic failover. Use something like a traffic manager with multiple region stamps, and you can easily fail between them. You got to have monitoring in place. You can't know to fail over from one region to another or one data center to another if you're not monitoring or alerting. You don't want a customer telling you something went down. And finally, if you do make plans for recovery, for backup, for BCDR, for failover, have a procedure so that people that are handling the operations that are in your NOC or SOC or whatever, they know what the expectation is. They know how to fail it over. They know how to fail back. And you've tested it. Tested on an off-peak day. Because if you never test your procedures, you don't know if they'll work when you actually need them. So those are a couple of considerations to definitely keep in mind with reliability. Now looking at security, definitely design from the beginning for security. Trying to add security features after the fact is usually much more difficult, and it's plugging holes in a wall, and it can be a challenge. And so understanding some of the security asks and requirements ahead of time help make sure that you haven't kind of gone down a path that might have a dead end. So the threats are always emerging, especially with the growth of AI, with the growth of quantum. We're going to have changing requirements on encryption, changing requirements on security. Today, the best standards we have for like authentication are with OpenID Connect and OAuth. Leveraging those and understanding that evolving landscape is important. Having something like a SOAR system or something like Sentinel and Azure Monitor, where you can go through and validate your baseline and monitor things. We get a lot of information around security from our customers. One of the biggest ones is like financial or HIPAA, healthcare type of organizations. So they have a lot of needs for encryption at rest, encryption in motion. So we're very concerned about access. So using like purview and data protections around customer data, financial data, healthcare records, understanding compliance and regulatory needs. So this is where Advisor, which I'm going to bring up the portal. We're going to go through quite a few of these things, but this is where those can help. Understanding like don't open a lot of services to public HTTP access. Always use private endpoints, private networks where possible. These will help just layer on that defense in depth. You need multiple different techniques to cover various aspects, and you need to monitor it constantly. Same applies to identity, like reviewing identities, trying to keep your production and your non-production workloads and identities and deployment pipelines, all of those things separate, so that you don't like mix and match and understand that, oh, I have a more lax stance in dev, but it's okay, we'll lock it down in prod. It's very easy to forget something and leave it behind and then have vulnerabilities in production. There's tools that will help with that, and we'll touch on some of those. Cost. This one comes up all the time. People moving from on-prem into the cloud, or people that are running things constantly in the cloud and don't have very strict cost management practices in place. They look at just looking at changing a SKU, going from like 16 core to 8 core, going, hey, I'll just drop it down to manage my cost. But there are a lot of techniques and things that you can leverage that we're going to talk about and show in the Well-Architected Framework. Specifically, understanding the cost model of the cloud. The cost model of the cloud is based on what you consume, what you use. And so one way you can leverage that is doing scaling resources, having auto scaling, having additional instances added. I talked earlier about minimizing over provisioning. So this is something where people add buffers to things and think they might need it. Designing for smaller scalable workloads that you can add more instances of is usually more cost effective than having one massive server, because it's either state or session or something might exist in that large workload instance, and it makes it harder to add a second one. And if you add a second one and it's usually the exact same size, your costs go up very, very quickly because you're just doubling the size of your thing. But if you have a lot of smaller, more granular workload units, you can scale them more independently and have a little bit more fine-grained control. Um, Understand why you're scaling, like trying to correlate your costs with the performance metrics. So are you monitoring the user experience, the response time, the CPU? It might not just be tied to CPU and memory. It might be response time. It might be transactions per minute. Understand the metric that you are scaling against. It's not always CPU and memory. A lot of cloud services, Azure especially, has an amazing variety of cost management tools. You can understand exactly where the cost is coming from by resource type, by resource group, by region. You can leverage tagging to break things down by business group or workload or application. So going through and leveraging those tools and reviewing them regularly is extremely important. A lot of times when you're in the cloud, you've shifted from like a CapEx model where you're just buying hardware once every amount of time and paying a license every amount of time to an OpEx model where you're being billed potentially per minute, per hour, per month based on the resource and the consumption you're doing against that. So understanding that shift in cost helps you design around that a little bit. Operational excellence. This is DevOps. This is understanding that we want to continuously improve and have processes. Processes about how we build our software, how we develop our software, how we deploy our software, how we run our software. Do we have monitoring in place? Do we have rollback? Is it automated? So going through and understanding the core of this, which is a framework and a process to build and deploy and run and monitor all of our solutions. This touches everything, and it could be that you have all those teams inside your organization and they have communication gaps or expectations on how things are built or deployed or tested. Using these pipelines, using automation, having consistent build and deploy, understanding that is really a part of operational excellence. Like I said, it's beyond build and deploy. It's how you run things, how you deal with incidents, how you monitor, and how you leverage those. Like, do you have a method to monitor, capture logs, capture metrics? That's where we live in the operational excellence pillar. You might monitor different things for reliability. You might monitor different things for cost. You might monitor different things for performance. But operational excellence is around, are you leveraging the tools and do you have this holistic picture of the state of things? And finally, performance. I've worked with many teams dealing with performance, and sometimes it's we need to pay the page to load fast or handle a large number of users. And I ask them very quickly, how many users? What is the response time? What is the load? Like, what is your actual performance goal? Are you looking at your historical traffic and saying we historically see, 500 users a day? We want to be able to look at that, over time. So look at the historical data. We had 400 last year and we have 500 this year. So we expect, our growth target is X amount. So we want to be able to go to 600, but we want the solution to scale for 5 years. We expect to get up to 1,000 per minute within the next 5 years, or 1,500. So let's try to design something that can scale to that. Like, use real numbers. Don't use gut feelings. Use historical data and measurements and understand the real ask. Then you can look at the actual SKUs. You can look at the actual architecture and the throughput, and you can design around those real numbers. Otherwise, it's, maybe for mom and pop, they say they need a Ferrari, and they maybe don't need the Ferrari. Maybe they just need, a Honda Accord. understanding those requirements and those real numbers are what's important. So for large global retailers, they need that same level of performance no matter what the load is. So that might drive for performance some sort of auto scaling. You might add additional load balancers. You're going to run load tests and benchmark the workload. You're going to look for those single point of failures. You're going to look for bottlenecks where traffic is being routed. You're going to understand the code and see if things are getting into a hot loop that is, affecting performance. Maybe you offload things into a CDN. So there's lots of different techniques depending upon what the requirements are. These are where those non-functional requirements come into play, and other times it might be functional requirements. Like it could be we need this many messages processed per second, or we need some sort of system where it leverages messaging so that we're not bottlenecking on message ingestion, and then we can scale out during the processing. So a fan out, fan in type model. And again, going back to understanding cloud patterns. So we've talked about a lot of pillars, and I want to get out to the site so that we can look at the well-architected framework itself. But before I do, I want to talk about trade-offs. And the first one I see almost all the time is understanding that you have to apply the trade-offs to the business priorities and the business requirements. You have to have a justification in my mind for why you're picking A over B, because there are different things that push back and forth against each other. Reliability and cost is the biggest one that comes to mind. This comes up a lot, but also performance, OpEx. Like, do we want to have monitoring at that scale? So all of these things are trade-offs that we have to think about and assess. But like with everything else, review it, go back, iterate, make adjustments, make improvements. So this is one I see a lot. I've helped a lot of customers with reliability. I've done reliability reviews for healthcare products, for large retailers that are global. And, we talk about reliability, and depending upon your need, if you want, we've had someone come in and say they wanted 4 nines, 5 nines. It's like, okay, to get to that level of reliability, you're going to need not only data center outage, capability, or surviving a regional outage. Maybe, you're using multi-cloud. So at that point, you have the whole cost of your solution 2, 3, 4 times. The cost goes up exponentially as you go from 3 nines to 4 nines to 5 nines. Going down to like 5 minutes of downtime per year for your entire solution. And so when we give recommendations on reliability, a lot of times they go, yeah, but our bosses don't want to do that because it's expensive. And so this is where that first trade-off comes in. What is the business requirement? Like the real requirement, do you have a budget? And what is the maximum reliability you can fit inside that budget? So looking at these trade-offs, this is where you start having to make tough decisions and document it. Back to those architectural decision records, ADRs. So do we need the reliability and uptime guarantees of multi-region redundancy and unmanned failover? Or is it, okay, we can handle an outage, but we need recovery very quickly. So maybe we're not hot, maybe we're hot, cool, but we'll redeploy our solution into the secondary environment as soon as there's a problem, and then restore backup and get going, and we can be up in under an hour. That is something that some people decide, because it's a lower cost solution that still gives you recovery, but not as much uptime and reliability. There's also the concern of if a region goes down and you're doing this redeploy into another region, how many other organizations have made that same decision and are going to be trying to spin up resources at the exact same time in that other region? So there's all these design decisions to think about, like what is the core requirement and business impact. If something goes down, are you losing hundreds of thousands of dollars an hour? Or is it hundreds of dollars an hour? Or is it millions of dollars an hour? So at what point do you hit that that, you know, equilibrium point where it makes more sense to just run multiple instances in multiple places, or maybe change your design. So if you're running on like VMs or single instance servers, maybe you move to a higher SKU for data that is, you know, hypercritical. And so you have a global database that handles synchronization for you so that you can, you know, have multi-region read and write. This is where those trade-offs come in. Another one that I see a lot, security and performance. So security versus performance, maybe some of the design decisions made by a financial company with multi-layered authentication, encryption, vulnerability assessments, maybe that's not the same trade-off that a gaming platform might make. They might have login and two-factor authentication, but then once you're in a game, they care about latency. They care about performance. You want to be able to play the game with minimal latency, minimal lag. And so adding additional protocols and additional routing, maybe that would affect. So every organization, every business requirement has slightly different needs that are going to lean you towards one pillar or another. Operational excellence and cost. So, you know, government services, financial companies, healthcare, extensive monitoring, extensive incident response. They need to know when things are down. They need to know the software bill of materials. They need to know if something's down, how to get it back up, proactive maintenance. Maybe in a startup, there is more limited investment in some of those tools. They leverage some things, but they use manual processes because they're trying to keep costs down. What's the real requirement? Because we always need to design for requirement, but also the future state. So, like, I'm always thinking that having deployment pipelines actually saves you overall on manual processes and cost, but maybe that means we're going to do less monitoring. We have super extensive logging and monitoring. Maybe we have more minimal logs in a startup. I don't know. It's a deeper discussion. Same with performance and reliability. These are trade-offs I see quite a bit of time, because when you do performance, you probably want bigger machines and more of them, more scaling. With reliability, we need redundancy. So one way I've seen these two kind of come together and combine a little bit is smaller microservices or containerized workloads where they can have clusters that can scale out into different regions or apply more instances as traffic shifts. So it can be a little bit more responsive, and they can scale down to very few instances. So the rapid scaling seems to help with that, but there is a lot of there can be a little lag during the failover, of course. You know, security and operational excellence. Same as you add more layers of security. For some, they view it as burdens. I'm more of the opinion that if you have a security incident, that could really affect your business to the point where it might not be there anymore, depending upon the publicity, the loss of data, the liability you're facing. It is a massive risk. So security is everyone's job these days, and it's something that I highly recommend not trying to wait till later to do. It is very hard to add security to things after the fact. And again, performance, operational efficiency, you see these type of trade-offs constantly. It's a conversation. Cost optimization. So I see a lot of times trying to do less logs, which can actually hide incidents inside them. So keeping the logs and doing analysis that is usually required. So we've gone through all the pillars, but there's some other tools, and I want to go get to them, like service guides. So well-architected framework service guides are incredible. When I was on a previous team inside CXP, I actually worked with the Worldwide Learn team and the skills team to help develop some of these service guides. And these take each of the Azure services and components that we offer and try to highlight the features and capabilities of them through the lenses of the pillars. So we go through each of the services and we say, like for reliability, these are the recommended configurations to help you prioritize reliability. For cost, here are things that you can do to affect cost. For performance, here are things you can do for this one service to affect performance. So they give you the building blocks to help build out the rest of your solution. We also provide out there in the well-architected framework, well-architected workloads. So there are some workloads that have already been designed for business outcomes that have like known use cases that help balance the functional and non-functional requirements, and they have deep discussions. And we're going to go out and look at them. There are ones around AI and virtual desktop and VMware. There's mission critical workloads, Oracle, SAP. So there's a ton of these. And let me just go out here and look. So if you go out to the well-architected framework, and you look up the Azure Well-Architected Framework, you're going to find this. And we have the pillars, the workloads, the service guides, there's training, there's assessments, there's the architecture center. And so I gave you a high-level overview and some deep discussion of some of the different pillars here. And you'll see we have in here a lot of different resources for you for each of these specific pillars. So there's training on just cost optimization out at Learn. There's videos on how to do some of the trade-offs for cost. We have a deep dive into design principles. So like we can go into the design principles and understand like, what's my cost model? What's my budget? There's checklists here. So you can go through and look at each one. So, I mentioned cost model. I can look at this cost model and there's a deep discussion on all of the terms like chargeback or a cost meter. There's design decisions that you can make. There's a discussion on the different billing models and customer agreements and licensing. So for each of the pillars, for each of the design principles, we also have, like I said, these checklists on how to think about the concepts behind this. So this doesn't just apply to Microsoft Azure. This applies pretty much to your entire career, that you can leverage the way to think about these problems and design these problems. And there is some discussion here around trade-offs. So, again, these are documented, these grow, and these have some way to like have more limited recovery, more limited complexity. So that's the pillars. Let's look at the service guides. So let me just go back to the well-architected framework. Here's our service guides here. Look at this. So for each service, we've gone through and tried to give you capabilities. If we look at this Azure App Service here. So again, here's our service guides. This is that quick links we were just at. But let's look at this. So for Azure App Service, for the web apps, container apps, things like that, or containers for web apps, and our app service plans, we talk about the reliability pillar. So they go through going, here are the things that apply to your app service. Like, have you thought about designing things in a certain way? Have you done your failure mode analysis for your app? Do you have redundancy? Like, do you have multiple instances? Do you have scaling in place? So scaling out, scaling up, looking at your plans. Do you have app initialization? So warm up. We haven't really talked about warm up, but in the context of an app service plan, we want to make sure that your app is warmed up so you're not going from a cold start. So this takes the lens of that pillar and applies it to this service to give you detailed, specific information. And if we scroll down, here are the recommendations. So the recommendations are actually settings and things you can do in app service to get a thing. So I can look at this SKU. I can check this box to enable resiliency. I can disable like ARR. So the features of App Service Plan, how they affect me. And this goes pillar after pillar. I can get specific things around security settings, or cost optimization. And so this applies to all of our services to help you make the best solution you can for the needs of your business. I highly recommend, if you've never seen these and you're building solutions in Azure, go check these out. Go look through these. Go check what you're thinking as far as why you picked the service or why you recommended this setting, and validate it here against the service guides. It is extremely valuable. All right, I want to talk about workloads now. So, workloads, there's actually a nice discussion about what is a workload and how to work with these workload teams, because it's lots of different stakeholders, it's lots of different engineers and people working together. So we've already designed a few different solutions, like looking at the mission critical workload. This one is awesome. It is really well designed. There's lots of discussion here. There's even training on it. There's videos against this. And so if we look at the pattern, it actually is a scalable pattern. So, maybe we have some sort of global data platform and router and monitoring, and we have regional stamps. We can stamp out our regions, so we can have multiple stamps if we want to scale out globally. We have discussions around why we're doing things a certain way. There's even, if you look here, it actually grows. So you have different capabilities. So like our baseline one, and if I go down here to some of the documents, so hey, we got our region, we got front door, we've got an AKS cluster potentially, and we got our regional stamp. Awesome. But maybe now we want network controls. Maybe we want to take this up a level and we want to have network isolation. And so now we can talk about, here's front door private link into the cluster. So we're now doing private endpoints for everything to make it more secure. They talk about how to expand this out over multiple regions, how to use build agents to work in those private networks, to use jump boxes through Bastion. And so there's discussions on, this is what we're using. Here's why we're using a globally distributed multi-write data platform. So it talks about the design decisions, going back to ADRs and why we're designing for this versus that. Here's where you can see some of these great discussions around why we're making those design decisions. What are our cross-cutting concerns? What are the things that we need to think about as we deal with our different workloads in the well-architected framework? We've got one on like SAP with different design decisions. We've got one around now AI. So AI workloads, where we need to talk about like the differences between ML and Gen AI, where we need to understand like maybe we're going to be building out a chatbot and we want to have private endpoints. We want to use the AI Foundry so that we can connect effectively out to the various services. We want to lock things down. So the workloads give us a great starting place and a great discussion around the various technologies. Now let me go back to the Well-Architected Framework one more time. I got about 10 minutes left. So I will go into training. So if you haven't gone out here, and I will have links at the end of this presentation, there's a great learning path available. And I have a link to this. This has about 6, I've done quite a few of these, but this talks about a lot of different products. You can find this as free training out on Microsoft Learn. It's one that is linked through the AZ305 certificate and exam. So like if you're studying for the 305 and you come down here to self-paced learning, you'll see there's a lot of different learning paths around architecture and identity and infrastructure. So there's lots of great ones, but one of those learning paths is this one around how to build solutions with the well-architected framework. And if you want to see some of these, like there's a good introduction to this, which we'll talk about the various pillars in more depth, but then for each pillar, they go in a little bit deeper. And so you can come down here and dive into the various pillars and just really familiarize yourself with the different capabilities. So negotiate performance targets. And so this will talk to you about what are these. Remember, we talked about, is it, a user experience? Is it messages? Is it something else? Like you can come in here and play around with all of these at your own pace. I highly recommend reading it and reviewing it. Another thing I want to get to is the Azure Architecture Center. So we talked about how cloud patterns change over time. Well, this is architecture and descriptions for reference architectures. So at one point in the past, the Architecture Center had a lot of boxes and arrows and not a lot of real examples. We've definitely worked hard to fix that. So, we have things like flowcharts to help you decide which compute you need to use if you want to use an app service or something else. Maybe we have a basic OpenAI chat architecture. And so there's not only diagrams and workflows, usually you will see down towards the bottom a repository where you can deploy the scenario. So not only is there a diagram, here's the bicep to build and deploy that solution. So they actually give you a starting place and reference implementation. So, here's your UI with all of the code. And so you've got solutions that build and work. And you're going to see a lot of these that build on the well-architected framework. There's a ton of these here. So you can come up here and you can look for whatever you might need to deal with. So cost management on Kubernetes. Cool. So there's a discussion of how cost works and how to leverage, different techniques and tools. Definitely use the skills. Like if you're not familiar with these places, try them out. Now I want to talk about the assessment tool before I get into Advisor. Microsoft out through Learn actually has a number of different assessments that you can take. There is one for the well-architected review, but if you just go out to Learn, so if I'm just on Learn, there are some assessments right here. There's certifications and credentials, but there's assessments. There are a ton of assessments that you can do for various services and techniques. But again, if we do well architected, and we look here, there's a couple. There's one for AI workload. There's desktop. But I want us to start with this one, though, just a general well-architected review. Now you can sign in and associate it if you want with your subscription, your Azure subscription, so that you can actually look at things over time and see how they improve and change. And you noticed here that there are a couple of different options. I'm going to just do the core well-architected review. I'm going to come in here and I can look at different pillars. And so there's going to be questions, because in order to design effectively, you need to know what your goals are. Like we're trying to keep our workload. We want to use the platform. We have some logic separation, and we've done some essential capabilities. So this is just an assessment, just a survey. You can come and answer, as honestly as you want. No, I don't check failure mode. And so once you have finished reviewing all of this, it provides guidance. And you can get a summary of your answers and the responses. So you can see your answer summary. You can see like a score, your overall result. You can export it, and then you can even do things through CSV. And then we can go look at the recommendations. So if we come down here, here's our recommendations on the ones that I answered. There's a whole bunch I didn't answer. But on the ones that I answered, these go back to those checklist items from our pillar. So when we did those pillar deep dives and we talked about like the cost pillar and reliability pillar, those checklist items, they have a priority, like which ones have more impact potentially to your business. And so this will take you right back to those recommendations and give you all the information you need. So you can quickly go through the results and then hone in on the areas where you can focus that will have good impact. So this is an amazing tool to leverage. If you've never done this, I would highly recommend doing this. And finally, I'm just going to go ahead and go out to the portal real quick for a second, because there's a thing out here called Advisor. So if you've not seen Azure Advisor, you can see that there are, you get an overview of various tiles and reliabilities and recommendations. You can get an advisor score. These feed back into, notice, the same exact pillars. And so they break it down. You know, this looks at your deployed configurations in Azure. So you can come out here and see the tiers and the assessments. You can look at the workbooks. And so if you're having a reliability problem, or maybe you're worrying about your costs, you can come out here to Advisor and look at the workbook. This will actually help you dig in to your resources, your recommendations, you know, look at how you might be able to optimize things based on commitments. You can dig into your individual usage based on what you have. And so these are tools to check, to play with, to dig into, to make sense of what you've deployed if you've already started down that path. So definitely dig into all of these things. Please reach out and connect. I will make sure that this is shared, but this is a link to the Well-Architected Framework to learn some information about Advisor and the Architecture Center. Please feel free to connect with me on any of those platforms and reach out. And remember, keep your Azure clean when you can. And thank you for joining me today. I appreciate it.